Hello students, welcome back. In our previous lecture, we had discussed about nitrogenous fertilizer, when to apply those nitrogenous fertilizer, different examples of nitrogen fertilizers, and the characteristics of nitrogenous fertilizer. Today we are going to dive into the phosphatic fertilizer. We will know a lot of things about phosphatic fertilizer, when to apply this phosphatic fertilizer, what are the examples of phosphatic fertilizer, and how we can classify the phosphatic fertilizer, and when to use these different types of phosphatic fertilizer. Okay, so phosphatic fertilizer are basically, from the name itself, it contains more phosphorus. Okay, along with other nutrients. Some, if some straight phosphatic fertilizers are there like SSP, it contains only phosphorus, as well as some secondary nutrient and micronutrient if there is. Then some phosphatic fertilizer, if it is complex in nature, then it contains also some other primary nutrient. So let's discuss. So generally, phosphatic fertilizer, I mean, when fertilizers are being recommended, that is in recommended in the form of RDF, recommended dose of fertilizer. So it is in the unit is N P2O5 and K2O per hectare. So it is kg per hectare. N P2O5 K2O. As phosphorus and potassium are always presented in oxidized form, so there is a conversion factor you have to remember. So for phosphorus, percentage P2, percentage P25, if you want to convert, then you have to multiply 2.29 with percentage P to get percentage P2O5. To get percentage P from percentage P2O5, you have to multiply 0.43. Again, I am repeating. If you want percentage P2O5, that means phosphorus in oxidized form, you have to multiply 2.29 with mineral form of phosphorus or percentage P. If you want to get percentage P, that is mineral form, from oxidized form, that is percentage P25, you have to multiply 0.43 with percentage P25. Okay. Now, phosphorus and K content, as I have already discussed, that is expressed in oxidized form like P2O5 and K2O. P and K content in plant and soil expressed in elemental form of P and K. But if when we are recommending fertilizer, or when we are expressing their availability in soil, then we use basically the oxidized form. Then based on availability and solubility of phosphatic fertilizer, there are three groups of phosphatic fertilizer available. One is water soluble phosphatic or phosphoric acid, what phosphatic fertilizer containing water soluble phosphoric acid. Okay. Second one is phosphatic fertilizer containing citric acid soluble phosphoric acid. Then another one is phosphoric acid, which is insoluble in both water and citric acid. So what is the relevance of this and what are the examples? Let's discuss. So first one is water soluble phosphoric acid. Okay, the phosphatic fertilizer which contain water soluble phosphoric acid, they are most suitable for neutral to alkaline soil condition. This type of fertilizer, phosphatic fertilizer, they are mostly suitable for neutral to alkaline soil. This I mean, these are applied when crops require quick start and short duration crop. When the crop is short duration and it requires quick start, this type of fertilizer are generally used. For example, and it contains mostly monocalcium phosphate and ammonium phosphate. Okay. Examples of phosphatic fertilizer which contains water soluble phosphoric acid, they are SSP, that is single superphosphate, which contains 16% P2O5, DSP double superphosphate, which contains 32% P2O5, and TSP triple superphosphate, which contain 48% P2O5. Then ammonium phosphate, that contain 20% P2O5 and 20% nitrogen. Monoammonium phosphate MAP, that contains 48% P2O5, 11% nitrogen. Ammonium phosphosulfate, that contains 20% P2O5 and 16% nitrogen. So these are some of the examples of phosphatic fertilizer which contains water soluble phosphoric acid. Then second one is citric acid soluble phosphoric acid. Citric acid soluble phosphoric acid. This contains basically the citrate soluble phosphoric acid or dicalcium phosphate. The form of phosphate here is dicalcium phosphate. The form of phosphate in water soluble phosphoric acid is monocalcium phosphate. Remember. And basically this phosphoric acid containing dicalcium phosphate, they converts to monocalcium phosphate in acidic soil. So these are mainly applied in acidic soil condition. This type of phosphatic fertilizer, that is the citric acid soluble phosphatic fertilizer, they are basically this citric acid soluble phosphatic fertilizer, they are basically applied in acidic soil. In acidic soil, they actually convert this dicalcium phosphate, it converts to the dicalcium phosphate, it converts to monocalcium phosphate, which is available for the plant growth. Then again, these are mostly suitable for acidic soil and long duration crop. Where the citric acid soluble phosphatic fertilizer is being mostly used, long duration crop and acidic soil. For example, basic slag, it contains 14 to 18% P2O5. Then dicalcium phosphate, it contains 34 to 39% P2O5. Then coming our last group is phosphoric acid, that is not soluble or insoluble in both water and citric acid. Okay, so here uh, basically it contains phosphoric acid in the form of tricalcium phosphate. Okay, in water soluble phosphoric acid it contains the monocalcium phosphate, citric acid soluble phosphoric acid it contains dicalcium phosphate, and phosphoric acid that is not soluble in citric acid as well as water, it contains tricalcium phosphoric acid or phosphate. It is suitable for strongly acidic soil, I mean having very high organic matter, and for long duration crop or plantation crop. That is very suitable, this type of fertilizer. Then for example, rock phosphate, it is water and citric acid insoluble phosphatic fertilizer, like it contains 20 to 40% P2O5. Then bone meal, it contains 20 to 25% P2O5. Okay, and they are mostly efficient when they are applied in powdered form and broadcast application, because here the rate of reaction depends on its availability and its reaction from insoluble form to soluble form. So they are most effective in powdered form and when they are broadcasted in the soil, not band placement. Then let's discuss about different major phosphatic fertilizer and their characteristics. For example, single superphosphate, mostly used phosphatic fertilizer, that is single superphosphate SSP. It contains 16 to 22% P2O5. Mostly we use the I mean calculation, while calculating the SSP we use 16%, 16 to 22% P2O5, where 90% is water soluble, 8 to 11% sulfur it contains, and it contains 18 to 21% calcium. It is a mixture of monocalcium phosphate and gypsum. So SSP is nothing but the mixture of monocalcium phosphate and gypsum. It converts to dicalcium phosphate in alkaline soil, and it is easily bound with aluminum and iron, and it forms aluminum and iron phosphate in acidic soil. It is water soluble, and water solubility reduced to 20 to 25% in 2 hours and less than 1% in 30 days. So it is a quick acting phosphatic fertilizer, and the water solubility is reduced after its soil application. Okay, 10 to 25% reduced in 2 hours, and more than, I mean less than to 1%, that means more than 99% insolubility after 30 days. So it converts to dicalcium phosphate as well as mineral phosphate, or I mean occluded or uh, you know bind phosphate, like precipitated phosphate. Then super digested compost, where compost is enriched with superphosphate, it is called super digested compost. Enriched superphosphate also contains, I mean 25 to 30% P2O5, where 90 to 95% water soluble, that is rock phosphate plus H3PO4 plus H2SO4, that is monocalcium phosphate or and calcium sulfate. Then ammonium phosphate, it contains ammonia and H3PO4 or H2SO4. Then monoammonium phosphate contains 12% nitrogen, 61% P2O5. Diammonium phosphate DAP, there's 16% nitrogen, 48% P2O5, or 18% nitrogen, 46% P2O5. Then ammonium phosphate sulfate, it contains 16% nitrogen, 20% P2O5. Then triple superphosphate, it contains 44 to 52% P2O5, 95 to 98% water soluble. Then nitrophosphate, it contains 50% water soluble, 50% citric acid soluble phosphatic fertilizer. Good physical condition and handling capacity. For example, Suphola, that is 2022, 1889, 15, 15, 15. These are different forms of Suphola based on manufacturer. Then ammonium polyphosphate, it was developed by Tennis Valley Authority TVA. Uh, okay, then bone meal, suitable for acid soil and long duration crop. Basic slag, it is acid and near neutral soil, it is suitable. 14 to 18% P2O5 it contains, and 80% citric acid soluble. Rock phosphate, it is used for highly acidic soil and long duration crop, basically plantation crop, uh, and acidic soil. it contains 25 to 39% P2O5, 33 to 36% calcium. So this was about phosphatic fertilizer. Let's discuss about potassic fertilizer. So potassic fertilizer, as we have also described phosphatic fertilizer in three different groups, potassic fertilizer again classified into two broad groups. One is chloride form of potassium, another one is non-chloride form. Why it is being classified in chloride form and non-chloride form? Because of its selectivity on application in different crops, right? So when the crop is a starchy crop, that there the sugar is or glucose or glycogen or sucrose or mostly it is a starchy crop, that means it is mainly used for carbohydrate, then that type of crop, chloride hinders the sugar translocation. So and again the foliage crop like our tobacco, where the canopy is itself economic part, there also chloride toxicity happens, and when chloride concentration is higher, then sugar translocation cannot happen, and the leaf burning quality is also reduced, okay, in case of tobacco. So chloride form of potassic fertilizer like KCl, that is called muriate of potash, it contains 50 to 60% K2O, and it is unsuitable for sugar crop, potato, tobacco, and as I have already discussed. The non-chloride form of potassium, that is K2SO4, contains 48 to 50% K2O and 17.5% sulfur. Then K2Mg2SO4 whole 2, that is 22% K2O, 11% magnesium, 22% sulfur. Then KNO3, that is saltpeter or niter, it contains 11% nitrogen, 44% potassium. It is used for generally fruit trees, tobacco, and potato. Then potassium polyphosphate, it contains around 56% P2O5, 24% K2O, and it can be both liquid and solid. So this was about a brief idea about phosphatic and potassic fertilizer. Then some of the macro and micronutrient sources let's discuss. Calcium, magnesium, sulfur fertilizer and micronutrient fertilizer. Basically, fertilizer incidentally applied by application of primary nutrient mostly. So basically micronutrient, what happens in case of micronutrient, the fertile efficiency of micronutrient is very low, and micronutrients are basically fixed in the soil. So their availability depends on the nutrient dynamics and soil organic matter and soil organism. Okay, because this make them soluble, and pH also affect the micronutrient availability more significantly. Okay, so we have to rectify the soil reaction and we have to maintain the soil health so that micronutrient fertilizer need not to be applied in the soil. uh, Again, gypsum, it contains 29 to 32% calcium and 18.6% sulfur. Okay, you have to remember this. Gypsum, what is the formula? Calcium sulfate dot 2H2O. Then ferrous ammonium sulfate FAS, that contains 16% sulfur, 6% nitrogen, 16% iron. Ferrous sulfide or ferrous sulfate, it contains 18.8% sulfur, 32.8% iron. Urea gypsum, it contains 4.6% calcium, 0.6% sulfur, 36.8% nitrogen. Then urea sulfur, it contains 10% sulfur, 40% nitrogen. Zinc sulfate, zinc sulfate, monohydrate, it contains 33% to 35% zinc, 17.8% sulfur. It is monohydrate. Okay, heptahydrate, it is mostly used. Zinc sulfate, heptahydrate, that is mostly used in India, and it contains 21% zinc. Okay, so these things you have to remember. Then micronutrient and their concentration for normal plant growth. Basically iron, it is required in 0.5 to 5 ppm. Its concentration varies from 0.5 to 5 ppm in plant. Manganese, its concentration varies from 0.1 to 0.5 ppm. Boron varies from 0.1 to 1 ppm. Zinc varies from 0.02 to 0.2 ppm. Copper varies from 0.01 to 0.05 ppm. Molybdenum varies from 0.01 to 0.05 ppm. Then about freeze and chelates. Freeze are basically a micronutrient fused with specially glasses which release nutrients slowly. So if it would release the nutrient quickly, then it will fix in the soil and it will not be available for the plant growth. So freeze, actually they gradually release this micronutrient, that is freeze. Then chelates, they are some of the chelates which make coordinated bond with different micronutrient, so that their losses can be prevented and it cannot be get fixed in the soil, and it can be easily available for the plant growth. Some of the examples of micronutrient fertilizer like iron sulfate FeSO4 whole 2, that contains 19% iron. Fe2O3 ferrous oxide 77% iron. uh, FAP 29% iron. FAS ferrous ammonium sulfate 14% iron. Iron chelate contains 14% iron. Iron frites contains 22% iron. Manganese sulfate 26% manganese. Manganese chelate 12% manganese. Manganese frite 10% manganese. Then zinc sulfate monohydrate ZnSO4.H2O contains 33% zinc. Zinc sulfate heptahydrates contains 21% zinc. Zinc oxide, it contains 78% zinc, the highest, and mostly used zinc sulfate, that is zinc sulfate heptahydrate, that contains 21% zinc. Then zinc sulfate, it contains 67% zinc. Zinc chelate, it contains 14% zinc. When we apply zinc in soil, we generally use 5 to 25 kg zinc per hectare. When we are applying foliar spray, we use 0.5% zinc. Then borax, it contains 11% boron. Sodium tetraborate contains 14% boron. Boric acid contains 17% boron. Soluble contains 20% boron. Boron frites contains 6% boron. Copper sulfate contains 21% copper. Copper ammonium phosphate contains 31% copper. Now this is all about like micronutrient fertilizer, and we have also covered phosphatic and potassic fertilizer here. Then in the next lecture, we will discuss about fertilizer dose, how to calculate the fertilizer dose, different approaches of fertilizer application, and about biofertilizer. Till then, if you have any doubt from this lecture or any part of the agronomy or any part of the agriculture, you can let me know in the comment section so that we can put another new video on that particular concept. So till then, keep reading, keep signing. See you.